Hello everyone, this lesson is on how do you balance equations. I would say that this is something that everybody, so whether you're doing GCSE, even A-level, is something that you have to nail, and it is probably the most often asked about revision topic is balancing equations. So I'm going to give you a couple of examples. We're going to go back to the beginning of what actually balancing equations means, a couple of examples, and at the end there's a couple of examples for you to try as well. First of all, let's look at the basics of balancing equations. So all chemical reactions have reactants and they have products. So reactants are your chemicals that you are reacting together. Your products are the chemicals or substances that are produced. Okay, below, just here, you can see I have got a balanced symbol equation. So it looks a little bit different. So the first clue that an equation is not balanced is it won't have any numbers like this in. Okay, now that's not to say that if it doesn't have those, it's not balanced, but that is the first clue. But that is a balanced symbol equation. It is the reaction of magnesium reacting with oxygen to produce magnesium oxide. Now below, I've just written out the masses, and I just briefly want to talk to you about the conservation of mass. So the conservation of mass is that all of the reactants must weigh the same mass as the products. Okay, so here I've got 10 grams of magnesium, 10 of oxygen. Therefore, you would predict that my magnesium oxide weighs 20 grams. Okay, that's conservation of mass, and balanced equations are no different, because if the masses are the same on either side, it means that the number of atoms on either side must be the same. When you have an unbalanced equation, they are not, which is why you must add in essentially extra atoms to balance out both sides. Now, something that people forget to do when they go back to revising balanced equations is to really go back to the principles, which is what we teach you in kind of year 7 and year 8, is looking at what we call chemical formulae. So all of these here, these are all chemical formulae. You need to be able to look at those and tell me how many elements are in that chemical formulae. Okay, you must start with this because you have to be able to do this to do the next step, and then our final step, which is balance equations. So if we look here at magnesium oxide, remember that in the periodic table, which I would recommend having in front of you for this video, you need to understand or at least recognise that all of the elements start with a capital letter. Okay, so notice how here I've got two elements. I've got magnesium and I've got oxygen. Capital M for the start of magnesium and a capital O for oxygen. So I would say that in that chemical formulae there are two elements, magnesium, Mg, and oxygen. Okay, now look at your next one. We've now got these little numbers to look at. Now those little numbers are directly attached to the element on its left. Okay, so first of all, split up based on the number or the capital letters. So capital N, small a, capital S, and a capital O. You've got 3 elements. Okay, now those little numbers we will only look at when we go on to the next step, which is how many atoms. Okay, again you can see on iron chloride we have got a little 2. We're just concerned about the elements. I've got a capital F, small e, which is 1 element. I've then got a capital C, small l, which is a second element. Okay, and my last one, we've got brackets coming into play. Now again, those brackets aren't relevant unless you are calculating the number of atoms. We are just calculating how many elements, so therefore we're going to ignore the brackets. So capital C, small a, calcium, capital N, nitrogen, capital O, oxygen. 3 elements. Okay, that's the first stage. We're then going to look at how many atoms. This is what we do for how many atoms. So I've taken exactly the same chemical formulae from the previous slide, but we're now going to calculate how many atoms there are. So you're going to split each of them up again into their elements. Okay, so we said we had magnesium and we had oxygen. Now there is one of each of those. There's no small numbers. If there's no small numbers next to any elements, you are assuming that there are one of that atom. So there is one of each of those. Now look here. Look at, this is sodium sulfate. You have got Na2. Actually, let's write out our elements. Na, S and O. You have got a little 2 next to the Na, 2. Next to the S, you don't have anything, so you assume that it is 1. That little 4 next to the oxygen means there are 4 atoms. Our next one, iron chloride, we have got 2 elements, and Cl. Nothing left to the to the right of the Fe. There's no numbers, so we assume it is 1. With the chlorine, you can see there is a little 2, so there is 2. Then the most advanced type of example is where you have then got brackets. These brackets work in exactly the same way as they do in maths. Whatever is in the bracket, you times by the number that is on the outside. Now, calcium isn't in the bracket and it doesn't have any numbers next to it, so we assume that there is 1 atom of calcium. Now, nitrogen is in the bracket. Now, inside the bracket, there is no 1 or no number directly attached to it. So we are assuming that there is 1 nitrogen in the bracket times by the 2 on the outside, which is here. So there would be 2 nitrogens. You are probably already thinking ahead and realising that there are 3 oxygens in the bracket times by the 2 on the outside, which is 6. So the last example there, the brackets, is the most difficult type of formulae you would get. Now the next thing we're going to do is we're going to go through worked examples. Okay, so I've just got a whole host of them here and I'm going to go through and answer them as if I was doing them almost in a test. Now the first thing I recommend that you do is you split your equation into half here. Okay, at the arrow. That way you've split the equation into your reactants and your products. Okay, the next thing you do is you list all of your elements out on either side. Now, because of the conservation of mass, every element must be on both sides of the equation. Okay, so we will have Ca, O, H and Cl. Look at the other side. We've got Ca, and I again would write them in the same order. O, H, and Cl. Okay, now I'm going to go through and I'm going to count. I'll annotate this one. I won't annotate the others, otherwise it will get a little bit messy. But I'll annotate how I calculate the number of atoms. So we've just done the number of elements, 4 elements on each side. Let's now do the number of atoms. I'll do it in a different colour. Okay, so if we split that here, we have got a calcium and an oxygen. If we split that here, that is a hydrogen and a chlorine. If you go to the other side, you've got a split down the middle here and a split down the middle here. Obviously the 2 is attached to the hydrogen there. And so we've got calcium, we've got chlorine, we've got hydrogen, we've got oxygen. So if we now go through and we're going to list all the atoms. Okay, so calcium, we have got no little numbers next to it, so it's 1. No little numbers next to the oxygen, so it's 1. Same for the hydrogen and the chlorine here, no little numbers. On this side, the calcium, 1. Now that 2 is connected to the chlorine, so it's 2 chlorine. The hydrogen, there's a 2 there, so that is 2. Oxygen, there is 1. And And yeah, and that's all of them. So now we look at how we're going to balance this. So you can only put big numbers into a chemical equation. I can't add, for example, you see how hydrogen and chlorine are 2 on this side. I can't add a little 2 here like that, okay? That is changing the chemical structure of the element, and I cannot do that. You can only add in these big numbers. So rather than put a little 2 there, I would put a big 2 like that, okay? I'm just going to tidy up the equation there. See if I can just rub these out just to tidy it up a little bit. Okay, so that will be your final balanced equation. I'll just finish it off. Just rub all these bits out so it's a little bit tidier. Okay, so going back then, by putting the 2 there, I have now got 2, so you cross that out, 2, cross that out, 2, and your equation is balanced. Next one, split it in half, list all your elements, P and Cl, P and Cl. Now you have got 1 P on this side, a little 2 attached to the chlorine. You have got 1 P on this side, little 3 attached to the chlorine. So straight away here, going to be quite tricky to balance because we're working with PCl3. I'm just going to show you probably the thought process that most of you would do. First thing I always say is that there's no point putting a 1 here. 1 times 2 is 2, so there's no point doing that. Remember, it's not 2 plus 1, it's 1 times 2, so there's no point doing that. The next thing I would always recommend to try is try a big 2 first of all, the thing you want to change. Okay, so that's now got 2 times 2, 4. You go back to this side and you can see that that's now difficult to get into a 4. Okay, so try a big 2 on this side. Okay, you've now got 2p, 2 times 3, 6 chlorines. You can see when we go back to this side, what I actually should have done, which you could have done first of all as well, is put a big 3 here to start off with. Okay, 3 times 2 is 6. You then need to balance your p's out, and you would put a 2 there, 2, and your equation is balanced. Next one, we have got sulfur and oxygen, sulfur and oxygen. Look at your sulfur. You've got 1 on that side. You've got a little 2, little 2. Add those together because you're going over the add sign. 4. On this side, 1 sulfur, little 3, 3. Okay, so again, very similar to the last one. We could straight away put a 2 here. Okay, that's not going to give us 4. It's going to give us slightly more than that. 2 times 3, 6. 2 sulfur. We come back to this side. I would start off by balancing your sulfurs first of all, because 2 into 1 is really easy. So you put a big 2 here. 2 sulfur. I'm just going to again tidy this up and just remove what I've written here. Okay, you can see that by putting that big 2 in front of the sulfur, I've actually also changed, because this comes as a whole, I've actually also changed my oxygens. 2 times 2 gives me 4, plus the 2 here, 6, and your equation is balanced. Again, I'm just going to tidy it up so you can see the final result. Like so. So 2SO2 plus O2 plus 2SO3. Last couple then. You have got carbon and oxygen, carbon and oxygen. 1 carbon, 3 oxygen. 1 oxygen here, 2 here. 1 carbon, 2 oxygen. Okay, so we look at our oxygens. We've got 3 on the left-hand side, 2 on the right-hand side. So automatically we need more on the right-hand side. So if we start here and put a 2, that gives us 2 carbons, which we didn't necessarily want, but it doesn't matter. 2 times 2 oxygens, it gives you 4. You go back over to the other side. Let's change our carbons first of all. Let's put a 2. That gives us 2 carbons, and you'll see already that has balanced our oxygens. 2 here with the CO, carbon monoxide, and then 2 already with the oxygen. Okay, and your equation is balanced. Now the next one is a combustion equation. So you've got this here. This is an it's an alkene, C2H4, being burnt in oxygen to produce carbon dioxide and water. And notoriously, these are really, really difficult to balance. And for a little heads up, you should always balance them in the order carbon, hydrogen, oxygen. So don't worry if you didn't already know that. That comes up. It technically is an A-level tip. Because you don't see many combustion equations at GCSE, or not very often anyway, but always balance them, 1 in carbon, then 2nd hydrogen, then 3rd oxygens. So you're going to list out all your elements, CHO, list them out in the order that you want to balance them in. Okay, and we'll put our oxygens here. Okay, so let's balance them all out then. So we have got 2 carbons this side, 4 hydrogens and 2 oxygens. This side we have got 1 carbon, oxygens we have got 2 here with the carbon dioxide, and we've got 1 there with the hydrogen, so 3 in total. Hydrogen, H2. Okay, so like I said, always balance them in the order carbon, then hydrogen, then oxygen. So let's start with our carbons first. 2 on the left-hand side. We need 2 on the right-hand side. The only way we can get 2 is by putting a big 2 here. Not only has that changed our carbons, it also changed our oxygens. Okay, so 2 times the 2 is 4, plus the 1 that is here, it's giving you 5. Okay. Now, ignore the oxygens for now, because we've said we balance it in the order carbon, hydrogen, oxygen. So for hydrogen, you've got 4 on the left-hand side. You need 4 on the right-hand side. The only way you can get 4 is by putting a 2 here. 2 times 2 gives you 4 hydrogen. And now you total up all of your oxygens. You've got 2 times 2, 4. 2 here. You have got, 2 times 2 is 4 plus the 2, 6. You come back over to this side and you now see that your oxygens are really easy to balance. You put a big 3 here, which has given you 6. 3 times 2 is 6. Your equation is balanced. Again, I will just tidy up all of this so that you can see. Okay, so our last slide then, you can have a go at these. Look at number 3. You will see that you've got brackets to consider here. What I would suggest you do is you pause the video, and then when you replay the video again, I will let this video carry on and you will see the answers. So good luck. If you want to have a go at the questions, please pause the video now. I will catch you on the next lesson.